Welcome. In this video we're going to discuss a few of the even problems in which students were absent for on Chapter 7 practice test for Algebra 1B. So if you're an Algebra 1B student and you were absent or needed some extra help on a couple of the even problems, here is the video for you. We're going to start with number 4. And number 4 says, it has a system and it says x minus y equals 4. And the second line says 2x minus 5 equals 8. When I take a look at this, the directions on the page tell me to solve each system of equations using the graphing method. So lucky for us, they gave us a graph. And the goal here is to see if we have on a coordinate plane if our lines intersect, or if perhaps, so let's draw an example. So if the lines that we are graphing, perhaps they intersect like here, and the solution would be at the point in which they intersect. So this little place where the two lines actually meet, we call that intersecting. Now another situation that we have sometimes when we graph is the idea, let's make that a little straighter, is the idea when we have two lines and they don't intersect at all. So maybe we start with a line here and another line. Actually, we can make these real lines. So a line here and then another line parallel to it. If a line is parallel, it will never intersect. So in this case, for the first case we had, we would have one solution. And that solution would look like x comma y at the point in yellow there. Here we would have no solution. And the reason we'd have no solution is because the lines would never intersect since they are parallel. Now parallel lines have the exact same slope, but with a different y-intercept. So when we take a look at our last option for when we graph, what happens when we have our first line and we graph it, and perhaps the next line directly over top? Well, there we have what we would call all solutions, or an infinite set of solutions. So we call this infinite solutions because the lines are intersecting at each and every single point along that pathway. So in that case, we're now going to take a look at number 4 and see what type of a situation we have here. Now when we graph, we can use both the x and y intercepts if the idea is in standard form, and in this case both of these are in standard form, or we can use y equals mx plus b. We often want to use the most easy idea for us. So when I take a look at this, I find that x and y intercepts for this first problem are probably the easiest. And in the second problem, the second equation, I'm going to want to solve for y because that doesn't look super easy for me. So let's go ahead and take a look at the first problem, x minus y equals 4. And in doing this, I have an x-intercept where y is equal to 0. So if I have x minus 0 is equal to 4, I get x equal to 4. And I put a dot where x is equal to 4. Right here. And I'm going to do the y-intercept next. Maybe I'll do it right on the side. The y-intercept is where x is equal to 0. And in that case, that looks a little bit like y int, as if it's one word. Maybe we can do a little finagling and make this look like y-intercept. There we go. I'm going to then have 0 minus y is equal to 4, which if I divide by -1, I'm going to get y is equal to -4. So I have this line where I have the two intercepts. We're going to draw them and then draw the line that matches them. Okay. The next thing I'm going to do is go to the next problem, or the equation rather, which is this guy right here. And since I'm running low on room, I'm going to post that information. I'm going to solve for y, so I'm going to rewrite it as 2x minus 5y is equal to 8, subtracting 2x from both sides. Again, trying to get that y by itself. I get -5y is equal to -2x plus 8. And continue to divide by -5 by all terms, and find that y in fact is 2/5 x minus 8/5. And 8/5 can be converted into 1 3/5. So the slope in this is a positive 2/5, and the y-intercept is -1 3/5. Now that's just past, the y-intercept is just past 1.5. So I'm going to do my best to write a dot just past 1.5. Let's do this right here, be really precise. It's a little high, so let's move that dot down. That's a good dot. Okay, so we have this dot right there, and we're going to take a look at that, and we're going to go up 2 and to the right 5. So in doing that, up 1, 2, to the right 1, 2, 3, 4, 5. So I have this dot is going to be just below right here. And I'm going to make that line connecting them. Actually, I want to color that blue so we can recognize that. That looks pretty good. Now where these lines cross, it appears that they cross at 4, 0. So we're going to check that 4, 0, which is this point right here, looks to be about where they intersect. So we're going to use that point and check it into both equations. So checking into the first equation, I take a look and I write 4 minus 0 equals 0, and in fact that checks out. To the next equation, it's a little sloppy there, let's fix that. I get 2x minus 5y equals 8. So 2 times 4 minus 5 times 0 equals 8. 2 times 4 is 8. 0 times anything is 0. In fact, this does check out. So the solution is 4, 0. Okay, there's our sentence. Thank you for tuning in for this. We'll come back and catch you in the next.